Good morning, dear students. Today's topic is fragmentation and segmentation. It is an important topic of operating system. I hope I'll be able to help you and be able to make each and every topic very clear to you. Fragmentation. What is fragmentation? Fragmentation refers to the condition of a disk in which files are divided into pieces scattered around the disk. Fragmentation occurs naturally when you use a disk frequently, that is, creating, deleting, and modifying files. At some point, the operating system needs to store parts of a file in non-contiguous clusters. This is entirely invisible to users, but it can slow down the speed at which data is accessed because the disk drive must search through different parts of the disk to put together a single file. Fragmentation occurs in dynamic memory allocation system when many of the free blocks are too small to satisfy any request. There are two types of fragmentation: internal fragmentation and external fragmentation. External fragmentation happens when there is a sufficient quantity of area within the memory to satisfy the memory request of a method. However, the process memory request cannot be fulfilled because the memory offered is during a non-contiguous manner. Either you apply first fit or best fit memory allocation strategies, it will cause external fragmentation. So basically, external fragmentation, free space is divided into small pieces, result of allocating and deallocating pieces of the storage space of many different sizes. One may have plenty of free space, but it may not be able to use, or at least use as efficiently as one would like to. It is an unused portion of the main memory. Internal fragmentation happens when the memory is split into mounted size blocks. Whenever a method requests for the memory, the mounted sized block is allotted to the method. Just in case the memory allotted to the method is somewhat larger than the memory requested, then the distinction between allotted and requested memory, that is known as the internal fragmentation. That is the result of reserving a piece of space without ever intending to use it. Means unused portion of the page. So what is the difference between internal and external fragmentation? I think it must be clear by now. An internal fragmentation, fixed size memory block square measure appointed to the process. And in external fragmentation, variable size memory blocks square measure are appointed to the method. In internal fragmentation happens when the method of the process is larger than the memory, and external fragmentation happens when the process or the method is removed. The solution of internal fragmentation is best fit block, and the solution of the external fragmentation is compaction. Internal fragmentation occurs when the memory is divided into fixed size portions, and external fragmentation occurs when memory is divided into variable size partitions based on the size of processes. The difference between memory allocated and memory and required space is called internal fragmentation, and the unused spaces formed between non-contiguous memory fragments that are too small to serve a new process is called external fragmentation. The other topic is segmentation. In segmentation, basically a process is divided into segments. The chunks that a program is divided into, which are not necessarily all of the same sizes, are called segments. Segmentation gives users view of the process which paging does not give. Here the user's view is mapped into physical memory. It is better to have segmentation which divides the process into the segments. Each segment contains same type of functions, such as main function can be included in one segment and the library functions can be included in the other segment. So there is simple no relationship between logical addresses and the physical addresses in segmentation. A table stores the information about all such segments and is called a segment table. Segment table consists of two entries, base address and limit address. It is the base address and the limit address. A segment table, it maps two-dimensional logical addresses into one-dimensional physical addresses. Its each table entry has the base address and limit. Base address, it contains the starting physical addresses where the segment resides in memory, and limit is it specifies the length of the segment. Let's have a look at the diagram, and the concept will be more clear. This is the diagram. We have the logical addresses space in which different segments are there, and these logical addresses are mapped into the physical address. Now, segment 0 is stored. This is the physical address space, and segment 0 is stored at the base address is starting at 500. So you can see the segment is 0, base address is 500. Now it ends at 1100. 1100 minus 500 is 600. So the limit is 600. Same goes with segment 1. Segment 1 is stored at the starting of 2500. So the base address is 2500. And 3300 minus 2500 is 800. So the limit is 800. Same as with segment 2. Segment 2 is stored at the base address of 1500, and 1900 minus 1500 is 400. So the limit is 400. Segment 3, it is stored at the base address of 4600 and ends at 4800. 4800 minus 4600 is 200. So you can look at the segment table. The base address for segment 3 is 4600 and the limit is 200. For segment 4, the base address is 3800 and 4200 minus 3800 is 400. So the limit is 400. I hope now I'm clear that this diagram is clear to you. So what are the different types of segmentation? We have two types of segmentation. First is virtual memory segmentation and the other is simple segmentation. In virtual memory segmentation, each process is divided into a number of segments, not all of which are resident at one point in time. They all are scattered and are saved at different locations. Simple segmentation. Each process is divided into a number of segments, all of which are loaded into memory at one time, though not necessarily continuously. They all are loaded at the same time, and in virtual memory segmentation, all are not loaded at the same time. So the segment table, the address generated by the CPU is divided into segment number and segment offset. Segment number is the number of bits required to represent the segment, and segment offset is the number of bits required to represent the size of the segment. Now, we'll study about the advantages and disadvantages of segmentation. Advantages include when we use segmentation, there is no internal fragmentation. The average segment size is larger than the actual page size, so there is less overhead. It is easier to relocate segments than entire address space. The segment table is of lesser size as compared to the page table in paging. Disadvantages is that external fragmentation is a result of segmentation. It can have external segmentation. It is difficult to allocate contiguous memory to variable size partition, and the memory management algorithms used in segmentation is a bit costly. Now, the difference between fragmentation and segmentation. Fragmentation is a phenomenon in which storage space is used inefficiently, reducing capacity or performance, and often both. Segmentation, process of dividing the computer's primary memory into segments or sections as discussed earlier. In fragmentation, memory blocks remains unused, and in segmentation, the segmentation works as a memory management technique to execute processes. So the conclusion, fragmentation and segmentation, they both are associated with memory management, but the difference between fragmentation and segmentation is that fragmentation is a condition that causes memory blocks to remain unused, while segmentation is a technique of dividing the processes into several modules or sections. I hope segmentation and fragmentation is clear to all of you. Thank you for your time.